Hello everyone, welcome to 360 on History, your one-stop resource for blogs, podcasts and videos on science, history and nature. Please check out the website 360onhistory.com, join us on social media and subscribe to 360 on History podcast on YouTube. You can also subscribe to the audio version wherever you get your podcasts. What you just heard is the sound of two black holes colliding. In 2016, two scientists at the California Institute of Technology, Mike Brown and Konstantin Batkin, hypothesized the existence of a ninth planet in our solar system. With mass 10 times greater than that of Earth, this planet would explain the weird orbits of some objects far beyond the planet Neptune. Since then, they and other scientists have been looking for Planet 9 to no avail. Then just last month in August 2020, different scientists put forth another hypothesis, that the weird orbits of these objects could be explained by a collection of bodies, one of which is Planet 9, and that all of these bodies are black holes. Well, that's all very interesting, but what is a black hole? It's not empty space. It is in fact a region of space-time where gravity is so strong that nothing, not even light, can escape it. And if light cannot escape it, we cannot see it. Hence, black hole. Scientists think that the smallest black holes are as small as an atom, but with the mass of a mountain. When a big heavy star from perhaps 5 to 65 times the mass of the sun runs out of fuel, it collapses onto itself, causing an explosion called a supernova. The explosion squeezes the remaining matter into a tiny space, giving the black hole its heavy-duty gravity. These are called stellar mass black holes, which can be up to 10 to 100 times more massive than the sun. This, by the way, will not happen to the sun because it is not massive enough. Our star will have a much less explosive, though no less spectacular death, when in about 5 billion years, it will turn into a red giant and will engulf Mercury, Venus, and possibly even Earth. Eventually, it will become a white dwarf with just about 50% of its current mass. But that's a long time away. So let's get back to our black holes. There are also supermassive black holes, which are inordinately humongous. The largest type of black hole with mass of millions or even billions suns. Generally, supermassive black holes are those above 1 million solar masses. Some scientists have started labeling black holes above 10 billion solar masses as ultramassive black holes. Over the years, observations have revealed that the center of most galaxies has a supermassive black hole formed at the same time as the host galaxy. Even our galaxy, the Milky Way, has a supermassive black hole at its center, corresponding to the location of a bright and compact radio source known as Sagittarius A star. This black hole is equal to about 4 million suns. But remember, this mass is compacted inside a small space, and that's why the gravity is so high. Research is still ongoing on the formation of supermassive black holes, but scientists think that they can grow by accreting matter due to their extremely high gravity or even by merging with other black holes. Primordial black holes may have formed directly from external pressure in the first moments of the Big Bang. These could have accreted matter, eventually becoming supermassive black holes. So, primordial black holes could have been the seeds of the existing current supermassive black holes. Fun fact, black holes were predicted by Einstein's theory of relativity, but he did not believe they could exist. because the idea was so bizarre. Many scientists have since then contributed to the theory that black holes do, in fact, exist. Initially, the idea of a massive body that even light could not escape its gravity was proposed by English astronomer and clergyman John Michell in 1784. So, how do we know black holes exist? Remember that immense gravity we talked about? That's how. This gravity pulls material into the center of the black hole, and we can see this material falling into it by the electromagnetic radiation it emits. Scientists study stars orbiting or flying by a black hole. When these stars are close enough to the black hole, they emit high energy light, which scientists can observe with satellites and telescopes. Black holes have some well-known characteristics. For example, an event horizon is the defining feature of a black hole. This is the boundary in space-time through which matter and light can pass only inward into the black hole. Once matter or light have passed the event horizon, that's it. There is no escape. Any object approaching the event horizon appears to slow down and to an observer seems to take an infinite time to cross over till it fades away and can no longer be seen. Typically, this happens very quickly though, taking less than a second. However, if you were to fall into a black hole, time would appear normal to you. At the center of a black hole also lies the singularity, a region where the curvature of space-time becomes infinite. The singularity has zero volume, but contains all the mass of the black hole. If you fall into a black hole and reach the singularity, you will go through something called spaghettification. You will be stretched so much that you look like spaghetti, and then you will be torn apart. After that, you will be crushed into infinite density, and your mass will be added to that of the black hole. A cool way to go, I think. Black holes can be static and rotating, and both can have a singularity. As gas and dust from stars and other objects orbiting a supermassive black hole at the center of a galaxy falls into it, it forms an accretion disk. This disk emits electromagnetic radiation that can be captured by our instruments. The extreme gravity of the black hole compresses the accretion disk till it reaches millions of degrees Kelvin and forms the bright active galactic nucleus at the center of a galaxy. Quasars are extremely luminous active galactic nuclei in which a supermassive black hole with mass ranging from millions to billions of times the mass of the Sun is surrounded by a gaseous accretion disk. The power radiated by quasars is enormous, and we are able to detect the electromagnetic radiation they emit with our instruments. A blazar is an active galactic nucleus emitting a jet composed of ionized matter nearly at the speed of light. For most of the time that we have known about black holes, we were never able to directly observe them. Then, in 2016, scientists announced the detection of the merger of two black holes. The merger produced gravitational waves, also predicted by Einstein, which were then captured by special instruments here on Earth. Since then, gravitational waves produced by many such mergers have been detected, some even indicating the presence of intermediate mass black holes, that is, those between stellar mass and supermassive ones. And what better way to end than to talk about our first ever view of what a black hole looked like. In April 2019, a direct image of a supermassive black hole and its vicinity was revealed through observations made by the Event Horizon Telescope. This supermassive black hole lives at the center of a supergiant galaxy called Messier 87. That image confirms scientists' predictions of black holes and their event horizon. Thank you for joining me down this road into the event horizon of black holes. See you soon.